Alright, this is Elma+Ash, and she's got her safety glasses and her gloves for this. And this is our PCR machine. I am going to walk you through in more detail, but we just wanted to showcase making sure you put the balance tubes in, balancing it correctly, making sure that lid is on tight because you do not want to run it without it. And check with your instructor for the correct times and speed that PCR machine should be on, because you're probably going to run more than one sample. But what even is PCR? Let's talk about it. PCR is a polymerase chain reaction. This detects genetic material and rapidly amplifies DNA to make it easier to read. And we use gel electrophoresis to see and visualize that easier. But let's talk about the steps of PCR. The first step is to denature. You want to heat up that DNA strand to separate the strands to make it easier to visualize. Second is annealing, which cools the reaction down and allows the primers to form. And the step 3 is extension, and this synthesizes new DNA, making it easier to visualize. And on our part, we collect our sample like we did in week 1. We incubate that and collect it in week 2 yet again, and that's where we create our DNA sample and we PCR'd for the first time. And we've also done some other PCR with other samples and with our DNA pellets and whatnot. But that is
Alright,
PCR.
some important things here that we forgot is the master mix. This is something that you use with parafilm, like Elma's holding here in this photo. And you want to pre-measure the loading die for all your samples, and then pre-measure the DNA ladder for just one. And same thing for your actual DNA samples, putting them out with the loading die and mixing it on the parafilm and then putting it into the gel is the proper way. But we may have done it a different way, but we still got the results, and that's what matters. And another thing was the PCR cleanup. PCR cleanup is very important, otherwise it could cause contamination with future samples and whatnot. So the modern way to do it is with spin columns with silica matrices according to the biolabs, and this helps clean out enzymes, nucleotides, primers from the PCR, and salts are used to help clean out the actual DNA. The old way was like some more dangerous chemicals that harm the machine and other samples. So now it is a bit safer. And the last thing is a nano drop. I did show a picture of it, not in this section, but nano drops are used to quantify total DNA. PCRs are more focused on RNA and proteins. So using a nano drop decreases the purity measurement and concentration of that DNA, and to help us purify the sample, making sure we have a good qualified sample for the PCR. You do not want to run a nano drop after the PCR though, as it will confuse the machine and it's going to read some of the UVs that you do not want to be read. So don't mix up your steps.